When a positive integer n is fed into a machine, the output is a number calculated according to the rules shown below. For example, starting with an input of n equals 7, the machine will output 3 times 7 plus 1 is equal to 22. Then, if the output is repeatedly inserted into the machine 5 more times, the final output is 26. When the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? Now there's two ways to go about doing this. We could either use algebra or count backwards. And in this video, I'm just going to count backwards. So I'm going to copy paste this rule right here and put it down here. So we go backwards. We start with 1. Next, we have to check how we can get to 1. We know that we can get 1 from this if n is equal to 2. But there's no positive integer n, which gives us 1 if 3n plus 1 is equal to 1. So the only way to get to 1 is to first get 2. So how do we get to 2? First of all, we know we can get to 2 if n is equal to 4, because then we have 4 divided by 2. Now let's check the other one. 3n plus 1 is equal to 2. So 3n is equal to negative 1. As we can see, in this case n will not be a positive integer, so this will not work. Which means the only possible way to get to 2 is to go from 4. Now how do we get to 4? This gives us 4 if n is equal to 8. So we know one way to get to 4 is 8, but there's another way. If we check this one, we see that 3n plus 1 is equal to 4, so n will be equal to 1, which means we can get to 4 by either getting to 1 or 8 first. So how can we get to 8? Obviously, we can do that by getting 16 and then halving it over here. If we take a look here, we get that 3n plus 1 is equal to 8. That will not give us a positive integer, so the only way to get to 8 is from 16. Now what about 1? We can get to 1 by going to 2 and halving it. So one way to get to 1 is by getting to 2. And as we can see from this previous example, the only way to get to 1 is from 2. So that's it. So let's count how many steps we've gone. We've gone 1, 2, 3, 4. And we need a total of 6 steps. So we only have 2 more steps. If we check 16 now, first we get 32, because we can divide 32 by 2. Next, let me clear up some space here. We try 3n plus 1 is equal to 16, which gives us 3n is equal to 15, so n is equal to 5. So we can also get to 16 by going to 5. We already know from over here that the only way to get to 2 is by going to 4 first. Now this will be the final step. First, let's try getting to 32. We can get to 32 by going to 64 and dividing by 2. If 3n plus 1 is equal to 32, we get 3n is equal to 31, and that will not give us a positive integer for n. So the only way to get to 32 is by getting to 64 first. Now let's try 5. We can get to 5 if n is equal to 10. Let's clear up more space. If 3n plus 1 is equal to 5, we get 3n is equal to 4. This will not give us a positive integer value for n, so the only way to get to 5 is if 10 is equal to n. For 4, we already know that the two ways to get to 4 are if n is equal to 8 and n is equal to 1. So this is 8 and 1. Let's make sure we've gone through 6 steps. 1, 2, 3, 4, 5, 6. Okay. So these are the 4 values, which will give us 1 after 6 steps. 64 plus 10 plus 8 plus 1 is equal to 64 plus 19, which is 83. So our answer is E.